Hello everyone, welcome to the Learning Cubicle. In the previous class, we have learnt about distance and displacement. And if you remember, when we were talking about distance and displacement, we have discussed an example of you going and meeting your friend at his place, which is opposite to your house and on the other side of this park, as shown in the diagram, right? And in the first instance, when you wanted to meet your friend in the morning and when the gates were closed, you have chosen a path which is this. And we have discussed that the total length of this path covered by you from your place to your friend's place is what we called it as distance. Now, for you to cover this distance, you must have taken some time. And definitely, we require some time to cover the distance that is from your house to your friend's house, right? So, this distance covered by you in some time is what we call it as speed. That's what we call it as speed. So speed is basically the distance covered in a given time. Okay, so how much time you take to cover the distance, this ratio is what we call it as speed. Now, let us imagine that you are going from your place to your friend's place. Let us take that you are walking from your place to your friend's place. You are going on foot. Then let us suppose that you have taken some 2 minutes time. Let us suppose that you have taken some 2 minutes time. And for you to travel the same distance, let us suppose that you have started going from your place to your friend's place in the same path. Let us take, you have started going there on your bicycle, let us suppose. You will definitely take lesser time than when you're going by foot. Now let us suppose that another situation where you are going from your place to your friend's place, and let us suppose this time your father has agreed to drop you at your friend's place on his bike. Okay? And in that case, you will take lesser time than this, somewhere around say 45 seconds. Okay? So here the distance is remaining the same. That is you going from your friend's place, so from your place to your friend's place. So distance is constant. Okay? The distance is constant. But the time taken by you is going on decreasing. The time is going on decreasing. So you must understand here that as the time decreased to cover the same distance, you need to understand that the speed at which the motion is happening is increasing. When you're going on your foot, you will definitely take a longer time. But that's not the case when you take a bicycle. And the time will be even lesser when you go on your father's bike. So, we need to understand that for the same distance, if the time taken is less, then the speed is more. For the time taken, for the same distance, if the time taken is less, the speed is definitely more. At the same time, if the time is fixed and if the distance covered is more, then the speed is also more. Like for example, you and your friend are going on a race, suppose. You and your friend are going on a race. You are going on your foot and your friend is going on his bicycle. Let us suppose that. Okay? And both of you have agreed upon traveling for 1 minute. For 1 minute. Okay? And obviously, your friend who is going on the bicycle will cover a larger distance in that 1 minute than you. Okay? So, if the time is fixed and if the distance covered is more, even then the speed is more. So, what we need to understand over here is that speed is directly proportional to distance when time is constant. And speed is inversely proportional to time when distance is constant. So when you are covering the same distance in lesser time, the speed is more. When you are covering greater distance in the same time, even then the speed is more. That is the reason why we get this expression, speed is equal to distance by time. Okay? So that is what speed is all about. Now, the units in which speed is measured. We know that distance is measured in the units meters, in the SI units, and time is measured in the units seconds. So meters per second is the SI unit of speed, and there are even other units of speed, which is kilometer per hour, meter per hour, miles per hour, all these. Okay, kilometer per hour, miles per hour are the other units of speed. You must be seeing these things when you're watching a cricket match on the TV. Soon a bowler bowls a ball, immediately the speed is displayed over there. So many kilometers per hour and so many miles per hour they give there. So this kilometer per hour and miles per hour are the other units of speed, but the SI unit of speed is meters per second. Am I clear about that? Right. So to sum up, speed is the distance covered by a body in a given time, or it can also be called as rate of change of motion. So speed can also be defined that way. Rate of change of motion means how quickly the motion happens or how slowly the motion happens. That gives you the speed. And we have discussed the relation between speed and distance and speed and time. And we have also discussed the units of speed. The SI units, meters per second, and the other units are kilometers per hour and miles per hour. Thank you.